Okay, good morning. So once again, we'll continue with where we ended last time. Last time we were talking about the if statements in Java programming. Now today, we want to talk about the repetition statements in Java programming. So I'm going to look at the repetition statements such as the do while repetition, and also we'll look at the multiple selection statements. Okay, we'll look at the break and the continue statements, how they are applied here, and also look at other logical operators and the control statements summary. So now let's begin by looking at the essentials of counter controlled repetitions. Basically, before I dive deeper into this program, the repetition statements in programming enables a programmer to write a few lines of code which will do a lot of things. Basically, without these repetition statements, you can write long code with so many statements, but all those statements are just doing the same things over and over, just repeating statements over and over and making the code very long. Do you know the implication of that? The implication of that is if the code is too long, it affects the speed of the program because the process has to process so many lines of code. And then it also affects the memory. Okay, it occupies a lot of space on the computer if the code is too much. So eventually, it makes the program less effective and also efficient. So now the gist of the matter in this case, if the code is very few, it becomes faster in terms of processing. It won't waste the space of the computer, and that way the program becomes very fast and very efficient. So now the programmers, the developers of Java, okay, and other programming languages, they thought of why can't we use few lines of code that will repeat so many things that we want. Hence this concept of what? Repetitions. The concept of repetitions, because if you write a few statements in programming and those few statements can repeat so many actions, then you're going to have a faster program and more efficient program. So that's the background information regarding the repetition statements. They make a program use less resources to do more. All right. So as we discuss these, we'll look at the various types of these. Okay, but before that, we need to understand certain requirements of repetition. So repetition requires a control variable. In this case, which is a loop, we call it a loop. Right, for it to work very well. It also needs an initial value where to start from, and it also needs an increment, okay, statement. How are you going to be incrementing? Is it by sequence, incrementing by 1, or you'll be incrementing by the difference of 2 or difference of 3? So you need to know these three things: the control variable, which is the loop. You need to have where to start from, okay, or whether we're going to be incrementing or decrementing. So all these are very essential for you to sort out the repetition. So for example, is the program, okay, which will repeat certain things. So this one, I'm going to go straight into this. This is the loop, okay, variable. We call it counter. So it means in this case, we'll be starting from 1 when, okay, repeating statements. We'll start from 1, 2, 3, 4, just like that. And then this, okay, the while here is this what you call the control, okay? We call it the control. So now this loop control tells us how far we should go in terms of repetition. So this one shows that we cannot go beyond 10. So we will repeat certain things, okay, or certain statements starting from 1 up to 10. That's what this means. So this is the loop variable and this is the control variable, which is supposed to tell us how far we should go. Okay, so if you put, for example, 20 there, it means you are going up to 20. Now, why is the increment statement? The increment statement is this one, the plus counter. This means the plus count, it means you'll be incrementing by 1. So you move like 1, 2, 3, 4, 5, just like that. If you say plus 2, it means you'll be incrementing by the difference of 2. So it will be 1, 3, 5, 7. So it shows, okay, it shows how we are going to increment. So from this statement here, you can see these three essentials that we have looked at: the control variable, the initial value, and the increment or decrement. So every loop, every repetition is supposed to have these, okay, possible, right? So this is just an example program that satisfies what you need. Look at it practically, don't worry. So now from the figure 1, which I've looked at, you can see, okay, the elements of counter control repetitions are defined in line 8, 10, and also 13. So line 8, 10, and 13. So these things that we have highlighted here, right? So line 8 declares the control variable, which is the counter, right, as the int. And the loop continuation condition line 10 tests whether the value of the control variable is less than or equal to 10. So it means it shows how far we should go. And line 13, if you remember, this shows the increment, right? We saw that there was plus counter, right? So now controlling loops with floating point variables may result in imprecise counter values and inaccurate termination. That's why we don't use the float as a type of a loop. All the time we use int, because int has no floating values. So when the statement begins executing, the control variable is declared and initialized. As you can see, it was initialized as 1. You start from 1. Then the program checks the loop continuation condition, that is, we said from 1 to 10. And if the condition is initially true, the body statement executes. And after executing the body's loop, the program increments the variable by 1, as we saw from there. Remember, the common logic error with counter control repetition is off by 1 error. So I find that if we use the floating points to declare a loop variable, we find that you're going to have those errors and to give you precise actions. Because 2.5, how do you repeat 0.5? What is the repetition of 0.5? What about 0.1256? So all those complications are avoided when you just use integer for the loop variable, right? So now so this is the program, okay, which is also which is in harmony with what we are discussing in this regard. Don't worry, I'm going to write our own program in a minute. So in the meantime, let's first of all understand the concepts. So for the first statement, you've got an example of repetition statements, and the most used is the for loop. It says how the for loop is. So for loop is a keyword, and counter is the control variable, which is initialized to 1. And the counter, okay, this is the loop continuation condition. So this is specifying how far we should go. And then the counter plus plus shows the increment, how this loop will be incremented. So this is very, very important, people. Okay, very, very important, because this loop is mostly used, but it is fixed. That's a problem. It always starts somewhere and ends somewhere. It's not dynamic, right? So now for repetition statement, the one that we have just looked at there. So its main syntax is as follows: for the initialization, you put the loop continuation condition, and then you put increment statement. This is just 3 things that you need to understand about the for loop statement. And then I will do separate these statements inside. The 2 statements use the semicolon to separate them. Okay. So the statement often can be repeated with an equivalent while statement. So apart from the for loop, we have also the while loop. So this is the syntax for the while loop. Okay, for this one, we initialize outside, the continuation is in the brackets after the while, and the statement inside and the increment inside. Okay, so all the three expressions in the header are optional. If the loop continuation condition is omitted, the condition is always true, thus creating an infinite loop. That's why you might omit the initialization expression if the program initializes the control variable before the loop. You might omit the increment if the program calculates it with statements in the loop body for no increment. So what are we talking about here, people? We are talking about this here. Okay. So there is, okay, counter there. Okay, so we are talking about this one here. Counter incremented by 1, or we can write it in this way. We can write it in this way or this other way. So these are different ways of writing increment by 1. Alright, so now we are talking about the other examples, like the actual ones. For example, assume that x is equal to 2, y is equal to 10, and if x and y are not modified in the body of the loop, the statement will be like this. Okay, int j is equal to x and y is less than or equal to 4 times x times y, and y increment by y divided by 2 is equivalent to the statement where you say increment, okay, j is equal to 2 and j is less than 80 and j plus 5. All right, so with programming, as long as you maintain the concept, you discover that you can write it in any way, but you maintain these. No, as you can see, we are maintaining the variables. Okay, these variables are maintained, but you can do anything this side, okay, after the equal sign, but remember, maintain these essentials. Right. So now look at these statements that we can use. Let's say, for example, vary the control variable from 1 to 100 in increments of 1. So this one, it would be from, okay, you start from 1, less than 100, increment by 1. If you are decrementing from 100 to 1, then instead of putting plus plus here, you put minus minus. Right? But if you are going to vary, okay, you are going to increment by 7 from 7 to 77, then instead of saying plus plus, you're going to say I plus equal to 7. It means you increment by 7. Even here, you're going to increment by 2. Decrement by 2, you're going to say minus equal to 2. So all the time, the sign minus or plus should be before equal sign, right? And then if you want to vary, okay, value is 2, 5, 8, okay, the difference of 3, then you increment by 3, just like that, right? So here's an example which I'm going to look at practically later on. Okay, so it continues. So initialization and the increment expression can be comma-separated lists that enables you to use multiple initialization or multiple increment. Right? So we are talking about this arrangement here. So for int number is equal to 2, int less than this, total plus that. Okay, so you want to increment it by 1, right? By its number rather, and also want to increment it by 2. So these, okay, these are possible. You can actually, if you want to increment multiple increment, you might use a comma to separate these. It's very, very important aspect here, people. Otherwise, once you forget a comma, it will flag error messages. So we are going to take this example of compound interest. You know, a person invests $1,000 in saving account yielding 5% increment. So assuming that all the interest is left on deposit, calculate and print the amount of money in the amount at the end of the year for 10 years. So use following formula to determine the amount. So there is a formula here, right? So you can see where P is original amount invested, R is the annual interest rate, and then N is the number of years, and A is the amount of deposit at the end of nth year. So we're talking about this N, which is the compound interest you're looking for. So how do you handle this? So the solution to this problem involves a loop that performs the indicated calculation for 10 years of money. So we're going to do the calculation, okay, for 10 years. It means we're going to repeat certain calculations 10 times for us to get what we want. So Java treats floating point constants like this one and this one as type double. So Java treats all number constants like 7, -2 as type integer. So we must remember that in this case, for us to achieve what we want, we must use int for the loop because we don't have to have issues with what we are looking for. So here, the catch is here, where it is highlighted. So we're going to say int year 1 less than 10 and you increment by 1. So we want to do 1, 2, 3, 4 up to 10. Then you calculate the amount for the specified year. So the amount is equal to principal, which you have entered there on top. Now we're going to apply the maths function. Okay, we are going to apply the power. Alright, so we have to use maths.power 1.0 plus rate and then comma year. So this here is the one that will come, they will be incrementing from 1, 2, 3, 4 up to 10. So in this way, we are going to find each year how much we are going to be having. So this is the output that you expect here below, people. So it will do from year 1 all the way to year 10 and how much you're going to get at the end of 10th year. So it's very important. Remember, if we didn't have groups, we are going to be doing this formula one by one. Okay, to the power 1, again to the power 2, again to the power 3. So now in this case, we simplify all those statements, okay, which are going to write repeatedly by just writing these 3 statements. We're able to see here, they will do what we want. So very effective, people, as a programmer, to know that concept very well. Right? So let's continue. So as you can see in the format specifier, okay, the percent 2 seconds, the integer between the percent symbol and the conversion character indicates that the value output should be displayed with the field width of 20. That is, print display the value with at least 20 character positions. So if the value to be outputted less than 20 character position, right, then the value is right justified in the field by default. Okay, so if the year value to be outputted were more than characters than specified in the width, the field width would be extended to the right to accommodate the entire value. So find that you have so many decimals, 0.5, 6, 7, 8, 9, 10. So to avoid such a big number, you specify the width of the number that you want. Right, so let's talk about the do-while loop. The do-while loop. It's also another form of repetition. So far we have looked at the for-while loop. We have looked at the for loop, and also have looked at the while loop. And this time we want to look at the do-while loop. So in this loop, the program tests the loop continuation condition at the beginning of the loop before executing the body. So if the condition is false, the body never executes. Okay? So then do-while loop tests the loop continuation after executing the loop body before the body always executes at least once. So when a do-while statement terminates, execution continues with the next statement in the sequence. So basically, what does it mean? So you're saying the difference between the while loop, the one that we looked at earlier, and the do-while is that the while loop tests the condition at the beginning before it executes the body. But the do-while will do the body first, executes the body, and it will check if the condition permits us to continue executing or not. So the body first is done, then test. But the while is first you test before execute. It's like, for example, they say, okay, you're given food, you say, I want you to eat this food. Eat it until you feel pain, okay, in the stomach to indicate that you are full. So you keep on eating, as long as there's no pain in the stomach, you keep on eating until you feel the pain. That's what the do wow is. First you do execute the body, and then you test at the end. But the wow, we are told, as long as you feel anything, you don't feel anything, eat. If you feel something, don't eat. So at the point of eating first, you are told, how are you feeling? Okay, I feel something, don't eat. So that's the wow do. So before you do something, you are tested before. But the do wow first, do that thing, then test at the end. So that's the difference between the wow and the do wow. Because all these they achieve the same things, but we want them depending on the circumstance. If you want to do something, then test at the end, then go for do wow. If you want to test before you start, then do the wow. Otherwise, they all achieve the same thing. All right. So this is an example here. Okay, so they do, and then you put the board here, you increment, and then you test at the end, as you can see from there. So this is what you call the do while. So the do while, okay, the brackets or the braces are not required in the do while loop if there is only one statement in the body. But most programmers include the braces to avoid confusion between the while and the do while statement. Thus, the do while statement with one body conditional statement is used as detailed as follows. So you do the do, then statement inside, then the while at the end. So I think I want to also encourage you, whether it's one statement or block of statements, please always do use the brackets like this. Okay. So these are the examples of programs which you can go through after you understand what we are talking about. Right? So right now, I want us to go to this, okay, to the summary, so that we can actually look at what you are, okay, what you actually interested in. Okay, so remember last time we talked about logic operators, okay, in Java. In the first lesson we had, that there are those logic operations such as the AND, OR, and the NOT. So these are also very, very important as you try to work with the conditional statements and the replication statements. You can actually refer to the first lecture, the one that we talked about, okay, to understand these things further. Right. As for now, I want us to look at the summary. So in this summary, we have looked at structured programming promotes simplicity. So Boehm and Jakofin, only 3 forms of control are needed to implement an algorithm. That is sequence, selection, and repetition, which I've looked at. So the sequence structure is trivial. Simply list the statement to execute in order in which they can be executed. Okay? Then the selection is implemented in one of the 3 ways. Remember, we talked about if statement, okay, which is a single selection. And we talked about if else, which is a double selection. And we talked about the switch statement with multiple conditions and multiple actions. So the simple if statement is sufficient to provide any form of selection. Everything that can be done with if else statement and the switch statement can be implemented by combining the if statements. So now the repetition is implemented in one of the 3, which we have looked at already, the while statement. We have also looked at the do while statement, and we have looked at the for statements. Don't forget these concepts in the exam, because your exam will be theory, so make sure that you understand these things very well. Then the while statement is sufficient to provide any form of repetition. Everything that can be done with the do while for, okay, the for can be done with the while statement. So basically these they can achieve the same things. So it's up to the programmer to choose which one you're comfortable with and apply it if you're repeating, okay, certain statements. Okay, so combining these results illustrate that any form of control ever needed in Java program can be expressed in terms of sequence, selection, and repetition. These can be combined in only two ways: stacking and nesting. So remember, okay, that we must able to understand those things for us to be very good programmers. Okay. So now these are the exercise that we can do on our own, but we're going to do, okay, our stuff here. Okay. So for example, find and correct the errors in each of the following segment of code. So you can try to practice this. What is wrong with this? Okay. But remember, we will do our own stuff. So right now I'm going to share the bin so that we can actually have our own stuff done practically. So what we want to do is, we want to write a program that will display, okay, numbers from 1 to 20 by incrementing by 1 using the for. And the other program, we are going to write a program that will display numbers from 1 to 20 with a difference of 2. Alright, so let's begin with the first one here. So let's go to the new project. Okay, I'll call it Mungushi 3. So let's just wait for it. Right, so now we want to start with a program that will display numbers from 1 to 20, the sequence of 1, just like that. So remember, the first thing to do is to declare the group variable. You call it I. Okay, so let's now do the for. So say for, remember, I start from 1, and then I should be less or equal to 20. Right, semicolon, then I plus 1 to increment it by 1. And then from there, we do system.out.print. Okay, print line. I want it to come there, so we'll display high there. So save this program and you run it. Okay, let's just wait for it to process to run. Because what we want to achieve, yeah, finally. So you can see now the program displays numbers from 1 all the way to 20. With the difference of what? With the difference of 1. So now to be actually incrementing from 1, 2, 3, 4, just like that. But if I want to increment by 2, 1, 12, just odd numbers starting from 1, 3, 4, just like that, then you have to increment it by 2. So how do you do it? So we'll modify the same program, but this time we'll say increment it by 1, by 2. So this is how you increment it by 2. So remember, so I plus is equal to 2, it means you increment by 2. So save this one and you run it again. So you see the difference now. Okay, so the program has executed. So as you can see, it's 1, 3, 5. So the difference is what? The difference is 2. So you can also do the difference of 5. Okay, you can do the difference of 5. Just change there. So I plus is equal to 5. It means the difference of 5. So let's see. There you are. So as you can see, 1, 6, 11, 16, just like that. But what about if I want to decrement from 20 going to 1? What do you do? So in that way, we are going to change the starting point. We won't start from 1, we'll start from 20. So we'll say start from 20, but you must be above 1, equal or above 1. You cannot go beyond 1. So we want to move from 20 to 1. Then we can increment it by 1. So decrement it by 1. That was your decrementing. So say minus 1 minus is equal to 1. So you decrement by 1. So let's run this program. Right. So you can see you're now starting from 20 going down. So basically, this is how you manipulate the statements of repetition. Just this statement has produced this result of 20 actions produced. So that's the power of repetition. Right. So now, with this, it's just the building block of what we've discussed, how you can manipulate these things. But the next thing that we're going to look at, how we can apply these concepts we've looked at, the selection and the repetition together to achieve something very powerful as a program. So in the meantime, I want you to go through these concepts on your own, try to master them. And in the next lecture that we'll look at now how to interpret a scenario, okay, and then apply these concepts I've looked at, the selection and also the repetition statements in Java programming. In that way, we are moving from elementary concepts to advanced concepts in programming. Thanks very much.